GLUint times this element's size. This element's data will be passed in, and then again, GL static. Uh-oh, did my stream die? Yikes. What is going on? Sorry guys, stream died for a second, so I'm trying to see what's going on there. Yikes. Stream is not holding up well with my internet at the moment. Let's see here. Sorry about that, guys. Stream died on me, so I'm trying to make sure that this is all okay. Losing a lot of frames. It seems to be stabilized now. Hopefully it'll keep that way. Apologize for that, everyone. Okay, so continuing on from where that is. Oh yeah, thanks. Okay. Okay. So the stream looks like it's back on now. Sorry for that. So what we just did is we have stored in our elements here. Let's see, where do we? And then GL static draw again. Because again, this data is not going to be changing, so we should be okay. I'm keeping an eye on everything to make sure it's still stable. So there are elements, and again, we can just copy this again, and it'll be the exact same thing, except now it'll be a vector of gluints. We want to call them that. And copy this as appropriate. So there is our element buffer object. So now we can load in all of the indices for our data. And this will be able to go through and describe, excuse me, this will be able to go through making sure the stream is okay. Please let me know if there's anything weird going on still. So, okay. Looks like the stream is okay so far. Cool. Good old Twitch failing out on me here. Alright. So now that that's all done, so we've got our element buffer objects all loaded up. Those are all set and ready to go. So now that we have those, we have our binding and unbinding. We now need to go to our draw method. So our draw method is pretty straightforward again. All it is we're going to go bool draw bool draw, and we're going to return true every time it's successfully drawn. And the only time it won't be is if our VAO is not created, or if our VBO is not created, or if our EBO is not created. Basically, if any one of those is 0, we do not want to keep drawing. Okay, cool. Thank you, Mrs. Mrs.? I hope I'm pronouncing that right. I apologize. Basically, if any one of those is 0, which is what that checks for, we want to return false and not draw at all. Otherwise, we can continue on. So the first thing we want to do is we want to bind the vertex array object to say, hey, this is the buffers we're using and everything. And then we want to unbind it after we actually draw it. So we're going to do that. To draw, what we're going to do is we're going to do GL DrawElements. And we're going to say that we're doing triangles, as discussed previously. We're going to give in the size of the elements, and then the data type. And we're going to go over this element, over this method in just a second and describe it. And then we're starting an index 0. So this glDrawElements method, which if we come over here, I believe I have right here. So the glDrawElements, what this is. So why do I use this? So the reason that I use this, I've had this discussion a few times. Maybe someday I'll change it, but I kind of like this consistently right now. You can use this without this. The reason I do it is because it really helps to highlight that this method is coming from within the class. It's not like a global method or a global variable or something weird like that. There are other ways to do it. So like what you'll see sometimes is they'll name, some people will name their objects m_ for member VAO. That's one way to do it. Another way that you can do it is, of course, lowercase m VAO. I use this because those are kind of unintuitive to anyone who's new. And on top of that, though, it's there's no consistent naming scheme out there. We were just talking about this the other day. I wish that there was one. Maybe I'll make one and try and make it consistent, universally used or something. But there's no consistent naming scheme. And so somebody new coming into the code trying to just read one single file can't really tell based on that where everything is. So what I've gone ahead and done is I use this to kind of signify, hey, this is coming from within the class, such as the example with our elements. Whereas if you look at our data here, you can clearly see there's no this, therefore it must be an input parameter. Visual Studio does color code it differently, so if you're using Visual Studio, you get that benefit, but if you're using something like a normal text editor, you won't see it. It's just the way that I do it for these tutorials. If it's really that bothersome, I can stop it, but yeah. Yeah, I agree. It does seem pretty clear for that class. It's just a thing that I've done for these streams, and I'm trying to be consistent with the streams. Maybe for the next one, I'll switch over to something a little bit different. That way you don't see that every time, because I know it does kind of clutter it up. So continuing on from here, going back to this method. The glDrawElements method takes in a few different things. The first thing it takes in the mode. This is where we put in GL triangles, or like I had mentioned before, there's triangle fan and triangle strip. Okay. Perfectly valid to wonder. This is where we give it the mode of how to draw it. And so this kind of signifies different things. You can use triangles, points, line strips. There's a whole bunch of different ones. You can look up online how they all render differently for each one. I'm not really going to go into that because really we just want triangles in this case. The next one is the number of elements to be rendered. So what you can do is you can actually have multiple arrays of indices stored within a single buffer. And so you can say, okay, only draw them starting at the range of 0 to 15 for this model, and then from 15 to 30 for the next model. So this count is how many of those indices in that first and second instance would be 15 indices to render, so that would be 15 in that case. In our case, it's going to depend on how big of a size of elements are. We're just going to render everything there. And again, this is where I say that caching things can really help your performance because you're not having to have so many different buffers and such. So that's the first thing. The next thing is the type. Now you remember that when we created our data, all of our elements were stored as glint. And if you actually look up the data type, all a glint is an unsigned integer. And that's why we have to pass in this GL unsigned int. But you can also make it shorts and you can also make it bytes. Either one of those is valid. You'll notice it's not floats, and that's because the indices are never going to be 1.5 or something. They're always going to be 1, 2, 3, 4. The other thing to notice is that they're unsigned. They're never going to be a negative value. They're always going to be positive. But you can use each one of these to kind of shorten up how much data you're going to need. If you know that your indices are only going to be like 100 of them, you could probably get away with like a short, whereas if you're going to need millions of them, you're probably going to want an unsigned integer. So that's kind of the first one. Oh, and one more thing, the indices. So this is a pointer to how far into your data to go. So remember how I said you could render 0 to 15 and 15 to 30 as two separate renderings, but store all of those in the same buffer? So that, in the case of 0 to 15, would be 0, but in the case of 15 to 30, it would be the offset into the pointer by 15, which would be the size of unsigned integer times 15 or whatever. We're not going to really cover that in this video. We'll probably cover it in the future when we start optimizing everything. But for right now, you don't need to worry about that. You just need a basic knowledge, which is 0, unsigned int, triangles, and then the size of our elements. So the final method that we need is we need our deconstructor. And our deconstructor is pretty straightforward. All it does is delete everything that was there. So we need to go through first, we need to check if we have a VBO, and if so, we should do the EBO first, because the EBO is dependent on the VBO. The elements are dependent on the vertices, and then the vertices are dependent on the vertex arrays. So we want to delete the elements first, then the vertices, then the vertex array. So we're going to start out by checking if there's an EBO, and if there is, we delete that buffer. 1, and this is going to be the same input when generating as when we generated, so we're going to just pass it in like that. So we're saying that we're deleting one buffer and that it's a pointer to EBO, which is signified by that and. And then we're going to do the same thing now for the VBO. Finally, once that's all done, we're going to go ahead and delete the vertex array objects, which in this case again is 1 and this VAO. Now the reason that we're not doing an if check for this is because we have to call the constructor to create this, and when we call the constructor, this should be fine. It would be safer, however, to check that, and that's again simple as just saying if this VAO and doing it like so. And the reason that this works again is because a VAO, a VBO, and EBO are always going to be a value greater than 0 if they were properly created. That's why up here we go ahead and we initialize them to 0 to make sure if they aren't, that they weren't. Is that? Yeah. Yeah. Sorry, somebody was just messaging me that and it looks like we actually technically don't need this. I did not know this, but you can also just do it this way because it doesn't actually do anything if that buffer doesn't exist. This is just kind of a good check still. I'm doing it to just be safe or whatever. I don't know. Anyways, so you can do that. You can also get rid of the checks, and it's fine. Anyways, so now... weird. Anyways. So now that we've gone ahead and we've created our actual vertices or buffer objects and all that, we've got that all situated. Now it's time to actually go and create a shape. So what we're going to do is we're going to come over here. We're not going to create an actual shape. We're just going to create a test shape class. So we're going to have test shape, which is our header file. And we're going to come over here and create one for the source file. Move our header file over here to kind of organize it better. And so let's expand that out now. So the first thing we need to include is we need to include that drawable, and we're also going to need to include our shader, because again, we're going to have some data that's going to be passed into the shader for our actual shape now. So what we're going to do is start out by creating this test shape class, which is going to publicly extend a drawable object. So that means we're going to have some methods that we're going to use and such, and we're going to also have some private stuff. We don't need any protected in this case because it's going to be, it's not going to be inherited from. And so we're going to have our constructor, which takes in a shader object. Whoops, did the stream end up okay? I saw it flicker. Sorry guys, Twitch is freezing up, it looks like on my end. I'm seeing a lot of delays here for everything. Currently working on trying to get this stabilized. Oh my goodness, all the drop frames. Are you guys seeing a lot of lag on your side? Tell what's going on right now. This is awful, Twitch. What is going on? Let's see here. What is going on? I don't think I have even. Let's close off that and that. So that's all fine. I don't know if I can lower my bit rate too much right now. Let's see here. Settings. hopefully that'll stabilize it a little bit for right now. Ugh. Alright. Okay, so there we go. I think I've got it stabilized now. I'm not seeing anywhere near as many drop frames. Ugh, don't know what happened. Okay, hopefully that'll keep in. I'll try and sort these out by the next stream. Okay, let me know if there are any other issues, guys. Feel free to say anything. Just let me know if there are issues, and I'll try and get my best to resolve them. Okay. Continuing on, test shape deconstructor, and then we need a few variables. So you remember I talked about how in our shaders, and we'll go ahead and we'll open up one of those real quick. So we come over here and we go to our vertex shader. We have these two right here. So we actually need to store pointers to those effectively in here as well. So we're going to have our position attribute and our POSATT and our color attribute. And so both of those are going to be used for that. And then again, we're going to go over to our test shape, and we're going to make sure that we include our windows.h and include gl/glue.h. And then we're also going to include test shape.h. So now that we have that, let's go ahead and start coding up these methods. The first thing we're going to do is we're going to create our test shape. Come on, Visual Studio, you can do it. Alright, so there's that. Okay. Test shape. So there's that, and then shader times shader, which has to call the drawable constructor, because again, we need to make sure that that creates this vertex array object for us to use. So that'll get called first, and then what we want to do is we want to bind the vertex array object. The reason for it is that it needs to be bound before we can go through and load all our vertices and stuff. So the first thing we need is we need some test data, and this is going to be blatantly stolen from online, but I'm going to put it on here. And this is just our basic shapes and colors and stuff for that image. This is the vertex data, and this is the element data. So you'll notice to start with that we have 4 points, but that there's actually 5 inputs. And the reason for this is what we're actually putting in there is we're putting in 2 parts. We're putting in the XY coordinates of the shape, and then we're putting in the color data as well. So what this will allow us to do is we only need 1 buffer rather than 2 to actually put in the same data. So we're going to bind that, and what we're going to do is then we're going to say this load vertices, and we're going to add in vData, and the size of that, because there's 5 elements in 4 rows, or in 4 rows, is going to be 20. We're going to do the same thing with our elements, which is going to be load elements vData, and that is just 6. So now that we've gone ahead and done that, we need to get our position attributes and our color attributes. Now you'll remember that I said that we had to add that new method to our shaders. And the reason for that is if we go ahead and do shader get attribute, and in this case it's going to be in position, and then we're going to do the same thing for color attribute. So now we have the position attribute and the color attribute. Now we need to actually go through and tell them how these are structured. So this is in 2 parts. The first is we need to enable each attribute. So we're going to enable H1 GL enable vertex attribute array, which all that takes in is the attribute that we want to enable, so we go ahead and do that. And this is also going to be bound to that vertex array object, so we only have to bind that once, and then it's all set up for that. So we go ahead and enable that, and then we have to tell it what exactly that is, how exactly that is set up. So this is kind of a tricky one. This is a bit of a heavier duty 1. So we have that, we have this one now. So this takes in a few different things. The first of which is an index, which is just going to be the attribute that we're using. So in this case, it's position attribute. Then we're going to need to give it, and I'm just going to stay on this and I'll read through these first. We need to give it a size. So we need to tell how many values in our array are associated with it. So in the case of our position, where it's actually going to be is it's actually going to be 2 data points per position. So this is actually going to end up being 2 for us. So we can come over here, put in 2. So that tells how many objects effectively are there. Then we need to go through and tell it again what type of data this is. In this case, it's going to be GL float because it's a float data type. We need to tell whether it's going to be normalized, which means is it going to be able to be only between 0 and 1, or can it be 0 through 100? In this case, we actually want it to be 0 through 100 or whatever we deem, so we're going to put that as GL false. Finally, we need to next we need to tell how many objects are how to explain this? Basically the stride. So each of these has, each data point here, there are 4 data points, 1, 2, 3, 4, and each one of them has 5 elements in it. So we need to tell this how big in number of bytes that is going to be between each data point. So in this case, it's going to be 5 times the size of a float. And basically that's how many, how much to offset for each element. So there's 4 elements. Each one is separated by the previous one, which is going to be a size of 5 times the size of a float. So that's going to be 5 times the size of float. And then we need to give it an actual pointer to where in that data it is. So basically, you'll remember that we discussed that the first 2 data points are going to be our position, and the next 3 are going to be our color. So this is offset by 0, but this is offset by 2 times the size of a float. So in this case, this is just going to be 0. But for our color attribute, which we're going to do now, which is just going to be the same code, but for this, we're going to actually have a little bit different. It's going to be 3 instead of 2, because there's 3 colors to each one. And then this is actually going to have to be cast to avoid times, because it's a pointer. And it's going to be that 2 times the size of a float. There we go. And so what this is basically saying is that we're offsetting each data point by for the colors by 2. So the first one will be these 2, which are just the position of that vertice, and then these 2 are the color for it. So that is actually it for our entire thing here. We can create our deconstructor, which really is just kind of optional in this one. There's not much of a reason to use it, because that's all going to get called automatically, so you know, it's just optional. But if you're doing like a model or something, you might want to clean up some of the data if that's used or associated with that. So that is our basic shape. Now it's time to actually go through and draw it. So going back to our test state, we need to go through and tell it to have a test object. So what we're going to do is we're going to come here and we're going to include, and make sure that I'm doing all of this properly. So we're going to do include test shape, and then we're going to come down here and we're going to have a test shape pointer, and then coming down to our test shape, or to our test state C++ file, we're then going to come right under, because we have to make sure we're using the shader, we're going to do test shape is equal to new test shape, and that's going to take in and this shader. So that goes ahead and sets up our shader to be used and all of that. And now that we've got that created, we can actually come down here and we just do this test shape draw. If we go ahead and we render this and start running it, you'll see that everything goes through and compiles. Slowly but surely. And there's our blank test shape. Now, you'll notice that it's white, and the reason for this is, again, we have to update it briefly because our original shader did not use, it used 3 inputs for the position rather than 2. So we're going to go ahead and we're going to do that, and then we're going to go through, I want to make sure one other thing that I just remembered. Did I uppercase those? No, okay, I didn't, cool. So we have to tell it 2, because again, it was trying to offset by 3 before, which was wrong. Whoops. And we also need to update this to be 3 now, because there are only 3 data points. Oops. And that actually does need to be 4. That needs to be 0. Sorry about that, guys. Let me change the shader and around and forgot about it. So there's that. That's got all of our color stuff. Finally, though, we have our out color going out, which is based on our in color. So we need to go to the fragment shader and make sure that this is actually being output correctly. And I believe that the name is different for this, if I'm not mistaken. Oops. Let's see here. Resources. And so, yes, so we need to have this actually use our input color. So we need to take this there. So that's all black for the time being because I goofed on something. What did I goof on? We have our invec3, outvec4. So I'm just going to be lazy. I'm just going to copy this all over like I had before. That, and then we're going to come over to our test shape. This is now just going to be position and color. That'll make our lives a little easier. And there's our test shape. So all this shader code does is we give it in our vec2 position and our vec3 color, which is only different in that name. So I'm not sure why that was being so silly. And then we have our in vec3 color, which is then given out to a vec4. So there's the basics of that, and that is how you render a very basic shape. If you want to change that shape around, it's actually pretty straightforward. You can actually get rid of this, and you'll just see the first half of that triangle. We go ahead and we do that. Now we only render that top half up there, and if we go ahead and we get rid of the other half instead, you'll see that it instead only renders the bottom half. And so that's how you can draw some basic shapes. You can go through and do a lot more with that. But that's the basic summary for today's video. I hope that this was a little bit better. I hope that it was a lot smoother than before. And I hope that this all makes sense. I did rehearse this before, as you can see. And I will have various links in the description below to kind of help out with this. And like I said, the shader video has been redone, and throughout the week I will be streaming my development of my own little game, Zombie Slayer Summit, which is just going to be a fun little generic first-person shooter. And finally, I want to go ahead and talk. Next weekend, I will unfortunately not be streaming. I am going to be away at that time. So I will not be able to stream that weekend. I will be streaming throughout the week, though, and I will be streaming the following week. So keep an eye out on that. And when I return, we will go over some more shape rendering. We'll start getting ready to actually start making some stuff with this. We need to get into camera views and matrices, which is going to be a little bit of a tricky subject. Luckily, we've got some libraries to help with that. And then once we have our cameras and stuff, we'll get into rendering complex models, texturing, that'll be pretty cool, and then maybe a little bit of lighting with some neat shader tricks. And then shortly thereafter, we'll be doing physics with Bullet 3D, which I have actually been playing with a little bit today. I would bring it up, but I'm afraid that that would break the stream because I don't know how my computer would handle all of that. So we're not going to show that today. Maybe in the next video, we'll show it briefly as a sneak peek. But I hope you guys found this informative. I hope that this was a good video for you guys and that you enjoyed it. Thank you guys for sticking with me. I know that I haven't been the best about practicing this, but I promise I am now. I've got projects to work on to make sure that I get this done. So thank you for tuning in. Hopefully I'll see you guys next time.